Hello, I'm Tim. I'm back again. So I forgot to turn the recording on when I was putting floor, but that's the only thing I've done, so it's fine. So remember in the previous episode we have researched the usage of floor, and from that we are able to realize that because of divided by 10 doesn't really necessarily work as we would expect them to. Because of first of all, it's what's below zero, it might behave a little weird. So I actually think just do it directly will actually automatically activate turnkite. Although I'm not actually that sure. But floor will always go to the one below it, and that's working perfectly for us. So we go 165 divided by negative 165 divided by 10. That's negative 16.5. Negative 17 times 10. That's a negative 170. So that works, and that's one on top of it. So that works perfectly fine. All right. So yeah. Remember, on top of it's a physical location because the actual scale is reversed. It's from the smallest to it's from smaller number to bigger number on top to bottom. So above is actually smaller because it's more closer to the top. And then we have a mark above. We already know the one below it, so we know the difference between two marks, the value between difference in value between two marks. So mark above we just plus 10. That's perfectly valid. And then we have into vertical position to mark below, into vertical position to mark above. These ones are from the top of the section here. Remember that the way that we are expecting this program to work. Actually, I haven't told you guys this before, okay? But it's my bad. But so way that I would expect this program to work is first of all the camera send out a feed on the 640 by 480 or 960 by 720 if you're in a high-res screen, and then that goes then that goes to one of the many images, 1, 2, 3, 4, 5 images being stacked together, and then we actually make each of these images with OpenCV rendering, and then so we have 1, 2, 3, 4 images that we actually make as a head-up display. And actually there's gonna be a fifth one that we make, the overlays here. But that's probably not going to be a part of the first version. Okay. And then in OpenCV there are a function that we are able to call that actually let us assemble these ones together. Like the left two, do it like this, and then the main photo, and then the main feed, do it like this, and then the two on the right, do it like this. And then so like you are actually allowed to just put the image together to form a bigger image. And I mean, that's really handy on the CV, right? So this one is from top, which means it's from here. And then so pixel to mark below and pixel to mark above. So like there's gonna be a little pointer here as you see, and there's gonna be a line from here to here, and then there's gonna be like some scale markings like this. And then we need to know how many pixels is this from the pointer to one below it, and how many pixels from the pointer to one above it. We know that the pointer will be in the absolute center of the mat, right? Well, not exactly absolute center, plus or minus 1 degree, because it's like it's an even number, you can't get half a degree. I mean, yeah, you know how like if you have 5 eyeposts, you pick the one in the middle, you get the third one. If you have 4 eyeposts, you pick the one in the middle, you don't really get anything. But if you go 4 divided by 2, you actually get the second one, which is not exactly in the middle. Like that's a theory, that's a spirit here, but it's really close to the middle, so we can just treat it like it's in the middle, right? Because there are actually no way for you to not make it the middle. Okay. Now let's say Once again, I apologize. Yeah. So we know what the distance is from a the distance in pixels is from the middle here to the bottom, and the middle here to the one on below it, and from the middle here to the one above it, which is and then we can use that to calculate the actual absolute location of these two, comparing with this. And then so that's what we did here, and that's what we did here. So like degrees to mark below times pixel per degree. This is perfect. I think that's pretty self-explanatory. And pixel to mark above, pixel between marks. So like we know how many pixels there are between each marks. I've gone through that in previous episodes. And we know how many pixels there are to the mark below it. So like there's gonna be like, for example, there's 60 pixels between marks. This one is a pointer has 10 pixels to the one below it, so it will be like 550 pixels to the one above it. Like I think that's perfectly making sense. And then we have vertical position to mark below and vertical position to mark above. Do from these, and then we center line subtract the to the mark above. Yeah, center line subtract to mark above. Remember when we are doing graphical design, the y-axis is reversed. So when it goes down, the y value goes up. So like for example, it's 0 here, it's 480 here. You know, now when it goes down, the value goes up. Okay. Now we have a to my center, and then minus to the pixel to mark above. So we have something like here, and then plus to mark below, and then we'll have something like here, right? That's perfectly making sense. We'll have mark values and the location of marks. So as you'll be like 9 marks being rendered, although only 8 of them are displayed. But you know, like if you get a little bit going away, and then there's still some tail left in text, and then like we want to render that properly, right? So that's what we're doing here. So although it's only gonna be 8 of them are completely displayed, there might be one that's partially displayed, and we want to get the details right, so we partially display it, right? And then I gotta check I didn't do the redundant. Yeah, hold up. Yeah, so I didn't define them up top. Okay, that's cool. It's actually a little bit of a bug in Pluma that if you search something and then you don't need it anymore, it remains highlighted. So I normally type 10 spaces just to remove the highlight. Yeah. So I have mark values and the location of marks. Hold up. Yeah. So and see, I actually think these ones. Yeah. These ones are belonging to steps, so I left them here B, just to make the entire structure clear. But the rendering stuff, I put them in global variables, which is not yet global, but it's gonna be a class variables when we are defining. I just call them global for some reason. But I think it's actually called global. I think, yeah. But anyway, like some of them are gonna be class variables, but these ones aren't gonna be class variables. These ones are just gonna be like private ones in the function. User chuck away, user chuck away, user chuck away. Right. So if pixel to mark below is bigger than pixel to mark above, which means, for example, it's the pointer is here, and the thing is the one below is somewhere here, and the one above is somewhere here. Like I'm exaggerating, but I can't get this into detail, so because it's only like hand, so forgive. Excuse me. Yeah, and then it's likely for the one. So and then so if this one is the pointer is closer to the one below it, then it is likely for the one below, for the bottom one, to be partially displayed. So like it is more than possible for one of the marks below the bottom fully rendered one to be partially displayed, right? And if this one isn't even happening, the top one, then no way it's happening. And same goes the other way around. If the pointer is closer than to the top mark on top, then if the top doesn't have a partially rendered scale mark, then the bottom isn't going to have one, right? So from that, we can see this. So location of marks 0. Remember, array in C++ start at 0, and same goes for C. Don't make some mistakes, okay? Otherwise, it's gonna come back and bite you in the A term, okay? Now, location of the marks to component 1, which means the top one, is 4 times the pixel between marks, plus the vertical position to mark above, plus the vertical position of mark above. So like you have the mark above plus one distance, 2 distance, 3 distance, 4 distance, right? Because like you can, I've actually write a document on this one. I may display exactly. So one of them may give you the possibility of if your pointer is between 2 marks, and then how many pointers will be there on the top, on the bottom, and stuff. And if it is exactly in location, it will be like on top and bottom and other stuff, right? So if you look at exactly, this thing is gonna get cut off like here, right, and here, like halfway to 9 and halfway into 1 and halfway away from 9, right? That's kind of just how you would expect it to work, yeah. Sorry, I accidentally closed the file. Yeah, there we are. And then you just get one less. Oh, hold up. Yeah, you see, I've actually made a mistake here. So when it goes on top, remember I said the actual value, when you goes down, the value goes up. When it goes up, the value goes down. So this one's actually minus instead of plus. We're gonna make that right? Now this one is still plus, but it's a good habit to keep them in consistent factors, although it is not absolutely compulsory. Now these ones are actually plus, because as it goes lower, they go on the bottom. But these ones are minus. Yeah. Right. Yeah, you see, I made a mistake again. Yeah. And there we are. Yeah, and then you see, so now it works. So like so the top mark is a 4 place pixel between marks above the mark directly on top of the pointer, and the bottom one is 3. 3 directly below the point of the pointer, the one directly below the pointer, right? And that makes perfect sense. And this one I also forgot that when you goes up, the value goes. Yeah, this one I also forgot when you goes up. Actually, in this one is by value I'm talking about the attitude value. So in this one, when you goes up, your attitude value, so your actual pitch is lower. So remember I said so like the actual marking for the pitch. So remember I said the pointers here: positive 10, positive 20, positive 30, positive 40, negative 10, negative 20, negative 30, negative 40. So yeah, so I got this thing directly in the wrong direction, right? And that's it's gonna be a problem and come back to bite me in the item, so I'm gonna fix it. Okay, so now I fixed it, and now it works, right? So yeah, so this is good. You know, I'm glad I'm actually doing this video so I can walk it through with you guys and then correct my own mistakes. You know, like I normally wouldn't get the chance to. I normally just goes through actually testing and then find the problem and actually debug it, which is still perfectly fine. But I mean, like, except the parts that I suppose there are breathing techniques I need to employ, which I didn't. Except this part, which is kind of unhappy for me because I need to just breathe. Excuse me. Yep. Except that I'm actually doing pretty good work here, right? So yeah, now we deal with boundary value. Remember, it doesn't actually go all the way to 360. It goes from negative 170 to positive 180, which makes 360 in total. Right, keep in mind they yeah. Because a positive 180, like, it's actually kind of a loop thing. So positive 180 equals negative 180. So it's negative 170 to positive 180 that makes 360. Like, that's, I know it's really weird, okay, but bear with me. Okay, yeah, but I mean, like, if you think about mathematically, I don't really think it does work that way. 170 plus 180, yeah, 350. But if you think about it in context, that makes way more sense, right? So yeah. And then these ones are just dealing with boundary value. If it's greater than 180, you go minus 360. So if it's 190, it's actually negative 170. And that's making perfect sense. And boundary value, if it is below actually, if it's below 0. No, if it is completely below 0. See, I'm making multiple mistakes. Like, during programming, it's okay to actually make mistakes. You know, like, even when you're designing electronics, it's okay to make mistakes. I mean, mistakes are actually opportunities for you to actually learn. And that's actually what matters, like, to me, right? I know people who just want to get it done. Like, I am actually one of those people who want to get it done, but like, I don't just bother myself if I just don't go all crazy if something doesn't work. Like, I'm able to stay calm and then like see and then take it as an opportunity to learn. And I think that's actually a really important attitude towards engineering and design, because like, I mean, this flexibility and this ability to say that I'm not wanting to give up and I'm not getting frustrated just because something doesn't work, having a good attitude, I think it's one thing. It's one of those very important things that can actually keep your passion up. And I mean, this is a job that, to the people who doesn't like it, extremely boring, and to the people who does like it, extremely enjoyable. So I mean, so I consider that keeping your passion up is actually one of the really important things that you can do to that for you to do, like in your projects. It's just a thought. Like everyone look at engineering in their own way, and everyone will be looking at everyone will be looking at engineering philosophy in their own way, and everyone will be looking at their everyone will just be looking, and then everyone will take the purpose of engineering to themselves and to the humanities a different way. Like, so there are people who are just doing it for money. I know, okay, because like it's pretty good pay. But there are also people who are, especially the people who are on top, like on the absolute tip of the pyramid in the field, that actually bring a like uncompromising, complete passion towards engineering. And I mean, I suppose I might be one of those people one day. I mean, right now I have the passion, but I don't have the knowledge. That's why you gotta go to university, Yeah, sorry about my laugh. Yeah, it's how I laugh. See, this one is 1 times plus 1 times on top. 1 times on top. Oh shit, I did wrong. Sorry. And then we paste. Oh yeah, and then I forgot to go through this one. So yeah, if you get a negative value, a value below the away. I think I made a mistake here as well. If it is below negative 180, yeah. I'm copy and paste the comment, and then I just didn't work that well. Yeah, okay. So if it is below or equal to negative 180, yeah, that word makes way more sense. Okay. I mean, you see, like I'm making mistakes as I go through these, and they I mean, I consider it perfectly okay. I know people who don't. Because I have my parents who don't think making a mistake is a good idea. I mean, they kind of they feel like they still says alright, but like they were with the attitude like I'm sucking it up because like I'm spending money on this thing and you're not giving me any result. I went to talk. I actually went to talk to my dad about it, and I told him like. This is literally how the entire thing works, Right? I mean, yeah. I'm not sure. Have you guys heard of something called a single stage orbit? It's a NASA project that was running in like last century, something like I think 1980s. And then let's search that. Yeah, single stage orbit. It's people are trying to create a rocket that goes all the way to space and then come back. Like a space shuttle. That goes all the way to space and then come back, and the only thing you need to do is to refuel the fuels to a to refuel the fuels for everything to work again for another launch mission. So you don't actually run into the problem of building multiple rockets and then every single time you launch, you go shoo, right? Yeah. Hold on, I'm trying to find the time. Single stage orbit, yeah. It's say NASA shuttle launch vehicle. Space shuttle for humans, STS. Nope. Hold up. yeah. 1995, right? 1995. 1971. Skyline. Hold up, see. Aerospike. Okay, Aerospike engine. I'm sorry, I'm Chinese, so I have most of my website in English, in Chinese. But yeah, X33. There we go. It is cancelled in 2001. Alright. So they kind of tell us that so it was beginning something like 1970, 1990. It was after 20 years of development, it was cancelled in 2001. The purpose, and then so, oh my god. You know, like this thing is actually, the purpose of this thing in itself is just a reusable launch vehicle. RLV was actually completed by SpaceX in 2016, 15 years after this mission, after this project was aborted. You know, so yeah, I was talking jibber jabber, a lot of jibber jabbers. Hope you guys are okay with that. Yeah, I mean, yeah, I mean that's actually a part of my it's actually a part of the point I make in my philosophy, you know. My philosophy. I mean, this philosophy is just like a personal view for the world, you know. It's not like the philosophy in PhD. Like that one was a little far away. I'm wanting to get one of those like one day, but I'm in high school, so not today, you know. Yeah, and then it's still the same thing. I made the same damn mistake again. Minus, 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 plus, 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 plus. You see, I said I'm actually okay with mistakes, and I am, but that doesn't actually mean I like them. So like, I still try to avoid them, and if you can avoid making a mistake, try to intentionally make a mistake. Just because I said it's okay to have mistakes, right? Just don't take me wrong. But it's important to realize that mistakes are okay, and it's part of the process, and you're allowed to make mistakes in order to actually build your success, the success of our project, right? So we're done with that. Now we're dealing with boundary values. So if this one is greater than 180, you minus 360, and if it is below negative 180, you turn. So if it is smaller or equal to negative 180, yeah, just check up with the one. Yeah, you see that's the same thing here, right? Yeah, so that's good, right? That's good. So the computer will react the same way if reading is exactly at mark, or if the reading is slightly below mark. Go through the process manually if in doubt. So like you can just treat like a so the computer will treat the case where the the computer will treat the case where the mark is exactly at a scale point the same way as it treats the mark is below the scale. The mark is close to, hold up, if pixel to mark below is greater than pixel to mark above. Yeah. So you will treat it like so your computer will treat it as if the pointer is close to the mark below, comparing with it is exactly at the mark. And then you can just say it is exactly at the mark below because they treat it the same way. Yeah. So like if you can go through the wizard process manually if you want to. I did it partially, which is a yeah. So like the point here is the vertical position to mark below and vertical position to mark above is the same, and then the way they treat these are the same, and then you calculate the boundary value. So like if it is exactly like in the middle, and you get a for example, if it's in the middle, it's 480 divided by 2, you get a 240. You minus a tidal height 80, then you get a 160. You know, like a yeah, get 160, and then a so this 160 is from a middle to the from the bottom of the title to the middle, right? And if you go towards the middle to the bottom to the top of the value display, you know, and if you calculate that, it's 4 times the pixel between marks. You know how many pixels there are between each marks, which goes, hold up, should be an integer pixel between marks equals a pitch display height divided by 8, which is gonna give us that one 400. Oh my god, 160 times that's 20. That's 40. That's 40 pixels. Let's say 160 below. So as I said before, this one to here is exactly 160. So that's working perfectly fine, right? And I mean yeah, and then if you go wait, what? Yeah, this thing to top is 160 as well. But it only goes to 120, so it doesn't even display it. So that doesn't work. Yeah. Guys, you see, as I said before, it's okay to make mistakes. So we know that in this case, it just kind of doesn't work that well. No. Why? No, it shouldn't. Say yeah, that's weird. Go like from bottom 1, 2, 3, 4, 5, 6, 7. It's a tree plantation problem. So there should be 9 marks. There shouldn't be any problem. Hold on, I'm trying to figure out where I went wrong. Okay. It's tree plantation problem. God. Okay. So if we go you know what, let's create a new image in GIMP. Now let's say create a new image in GIMP, and we're gonna figure out what's going on. Okay. So we will not have 640 by 400 pixels. We will be having how many? 480 minus 160 is 320 height by how many pixels is this? Hold up, 1 second. By 160. Yeah, man, that makes a perfect sense. 160. Yeah, now we have a weird little thing like this. Change the size to a just gonna change the size to 1, and there's gonna be a pencil, be black. So we have 1, 2, 3, 4, 5, 6, 7, 8, right? And then so if you have and then that's 9 lines, so that's perfectly valid. If you have a 0 mark here that the pointer points to, this one is -10. Let's make it bigger, shall we? Yeah, better. Yep. Yeah. It's only going to display 8. Shows 9. Then what did we wrong? You know what? I'm gonna just cut this thing. When I figure out what did I do wrong, I'm gonna open this again and do it on the video. Okay? I'll explain on video, but when I figure it out.